Hello, folks. Welcome to the Amazon DocumentDB Insider Hour. This is our episode 16, and today we are going to be talking about DocumentDB global clusters, and I'll walk you through a solution on how you can automate that. But before that, let me get you my amazing co-host on the show. Let's welcome Cody Allen.
Hey, what's up, everybody? Hey, Karthik, how you doing?
Good, man. How are you?
Well, technical difficulties. Right before our show, this microphone just decided it didn't want to work anymore. Like, I plugged it into USBs and multiple cables, and it just didn't work. So we're going to wing it today. I'm using the microphone on my camera, so hopefully it's coming in clear and we're good to go.
You sound perfect, man. You sound great.
No, it's good. We've had a lot of exciting features come out here recently with DocumentDB. A lot of new things that we're rolling out. You know, we talked about our Graviton 2 instances, our T4Gs and R6s that came out. And then we had another feature that came out a little bit of time ago, our global clusters. And I think that might hint towards something that's on topic for today. I might be leading to something.
You sure are. So let me, share my screen. Let's talk about what we are going to be doing today, right? So, yes, you're absolutely right, Cody. So we did launch global clusters. I still remember the date precisely for whatever reason, June 2nd of 2021. So, and I know like all of us on the team work with various customers. I happen to talk to a lot of our customers to get their initial feedback before the release, and also, after the release, and help customers onboard this new feature. Right. And also, there's like a lot of feedback, good feedback, constructive feedback that we heard from customer. And one thing that stood out was, hey, it's great on how global clusters work. And you guys today on the show will see how it would work. I'll walk you through some presentations. But one common piece that stood out is, the failover process when there is a disaster recovery, or even if it is a planned failover for a business continuity. It's a bit manual process. Can you guys do something about it? Right now, we do have, always we work on customer feedback and improve our products. We do have plans on making things better always, right? But in the interim, how we can help customers. So today we'll be talking about a tool that helps our customers to automate the failover process using simple Lambda functions and Route 53 and so on. So we'll go into all those details today. We'll take a look at what that solution looks like, and also I'll show a live demo. And that's the plan today, Cody.
Yeah, I think it kind of taking a step back for a second for folks that aren't familiar with the concept of global clusters, right? I think it's important that we go into that, and I don't know if we're going to talk about that when we go into your deck. Kind of go through why it's so important and what it is customers are doing, why they need that.
Oh yeah, absolutely. That's a great point. Yes. So the plan is I'll start with just a couple slides on what is DocumentDB, just to help the folks that are joining our show for the first time or learning about DocumentDB. So I'll cover just 2 slides real quick on what is DocumentDB and how it is architected, and then I'll jump right into global clusters architecture. And just for the folks on this call, on this show over here, we'll be talking about, how does DocumentDB global cluster work under the hood, right? Like a little bit more technical detail around how things work, and then cover on the functional use cases on what we hear from customers. What are the popular use cases for global cluster? And that's after all that, so after we set that context, the same level knowledge for everybody, then we jump into the solutioning part, Cody.
Perfect. Yeah, that's we a lot of folks that are moving to a managed NoSQL solution like DocumentDB. It's one mindset to go from a single instance to a cluster or replica set, and then to the whole cloud environment, a multi-availability zone, a multi-network kind of architecture. And what we're doing here is we're saying, all right, now take that to the next level, like take that even further to give you that resiliency, right? To give you that availability. Right. So I love it. Yeah, we need to go through those building blocks, kind of build up to that. So,
all right. Yeah, absolutely. Let's jump into it. Let's start with what is DocumentDB, right? So Amazon DocumentDB is a fast, scalable, fully managed MongoDB compatible database service. You can use the service to scale millions of requests per second with millisecond level latencies, right? So it's again a fully managed service by AWS. So often when our customers are spending too much time managing MongoDB on-prem, or even they want to build some new greenfield applications for application modernization or stuff, DocumentDB is a popular choice for our customers on the AWS cloud. Not just because it's fully managed, but also because it integrates with so many other AWS services, making the tech stack super simple, right? So scalability is the key thing in the architecture, and you'll see that just in the next slide when I cover the architecture over here, right? That scalability is the biggest strength for the service, right? And how, based on how it is architected. So talking about the architecture, DocumentDB is architected to separate storage and compute. So you can scale these components independent of one another, right? So the compute instances that you see on the top there can be scaled horizontally, meaning you can scale it out up to 16 instances within a cluster, or you can scale it up. And you can also do a combination. You can do an or and here, right? You can scale it up and also scale it out. So we support, like Cody was mentioning earlier, we go from T4G medium to R6G 16x. And if you want a bigger instance, we also have R524XL. So that's about somewhere from 2 CPUs all the way up to 96 CPUs in compute is what we support. And the memory increases proportionately as well. And these instances are distributed across 3 availability zones for high availability. And you can control which availability zones you want these instances to be distributed, right? So while giving you that control, we also handle the automation of distribution of these instances within those availability zones of your choice.
So Karthik, when you were talking about the compute layer, you said customers can scale up or they can scale out. Walk me through that. Like what is the difference between scaling up and scaling out, and why would I do one versus the other?
Yeah, great question, Cody. So, for folks that are coming from relational background, scaling up seems to be like relatively more familiar topic, right? Where you basically go from a smaller machine to a bigger machine, right? Or from a commodity hardware maybe to a beefy larger servers, and you typically scale up so that you can support more throughput, and you'll have more compute capacity, and you can have more memory and so on, right? Well, it helps with relational databases to increase your let's say connections, or increase the number of reads or writes per second, your throughput and all that, but it quickly becomes expensive, right?
Because if I have a small computer and I have all these production connections coming through it, it's not going to work, right? It's just going to run out of memory. It's going to run out of compute. Like it just can't function. So that's why I would get bigger, right?
You get bigger, right? Yeah. Now, how you get bigger is a question, right? So you can certainly, in relational world, we scale up, but we all know how expensive that computer could become, right? And also there is a limit, a practical limit, after which your infrastructure is probably going to be doing more time context switching than supporting your workload.
And then you have a single point of failure, right? If you make one machine so large, and it's doing everything you need it to, but what are you going to do when all of a sudden you lose something, right? If something goes down, and let's say you even have to reboot it, you're down.
Yep, you're down. You take the downtime, right? So that's the single point of failure is absolutely a big piece there. So to mitigate that is where the NoSQL databases, strongly recommend and promote the scale-out architecture, where instead of one beefier machines, you have multiple smaller machines, right? So that's the horizontal scalability. So now you can distribute your traffic across these smaller machines, so you can still achieve that high throughput, and you no longer have a single point of failure, because if one of the smaller machine goes down, the others automatically pick up. For example, in this architecture that you're seeing, if the primary instance that takes the writes goes down, a secondary instance, one of the replicas would automatically be promoted without you even being aware of it. You can certainly be made aware if you want to through subscription events and other features that the service provides, but you can quickly be up and running with other instance now supporting that workload, and then DocumentDB will automatically spin up another instance just to manage and maintain your SLAs.
So so we're scaling out, and even as we scale out, it's not like that overhead of going and checking on each of them and making sure there's okay. It's no, the DocumentDB is taking care of that for us. It's making sure it's doing health checks and then replacing those to keep us in that state that we need no matter what.
Absolutely, and that's exactly why it's a fully managed service. As customers, we want customers to focus on what really matters to their business and not worry about the underlying infrastructure problems. We are there to help customers with that.
Makes sense.
So that's about high availability through those scale-out architecture and all that, right? But also in terms of durability. So DocumentDB, if you look at the bottom layer now, the storage volume, to maintain high durability, DocumentDB replicates data 6 ways across 3 availability zones in that distributed storage volume, right? So you get high durability out of the box, regardless of the number of instances you run. And this is, again, very unique with this architecture, right? It's not like durability is no longer a function of the number of instances in a cluster. You can run like the smallest instance, T4G medium, and just one of that, you still get the high durability that you would get with the largest instance and 16 of them, right? Like 16 R5 24x large. The durability factor remains the same. We always give you that high durability, right? So that's pretty powerful for customers. And again, all the durability is obviously fully managed by DocumentDB. Now, the other angle, if you look at this architecture, is on how the tasks are managed, right? If you look at replication tasks, I talked about how the data is replicated 6 ways across 3 AZs. This is a very database-specific task, right? This task is offloaded to the storage volume. And why should you care about it? It is important to know that because your instances on the top do not participate in this replication. So what this means to you is those instances are freed up to perform more compute-heavy work, which is what your application servers that sit on top of this layer would want, right? Because your application servers want that compute capacity so that your database can perform the queries that your users are looking forward to. So that by offloading the replication task to the storage layer, we free up the compute instances. Yet another task, a database-specific task that we offload like that is backup. So backup is again offloaded to the storage layer, meaning the compute instances do not participate in backup. So what this again means to you, in addition to what I already mentioned in terms of freeing up resources, is you can now perform backup in the middle of the day during your peak traffic without bringing your systems down to a grinding halt, which is again very unique to this architecture. Try doing this with other services. I have tried that. I did not have good experience there. So by offloading these tasks, database-specific tasks to the storage volume, we are freeing up your compute instances to do more compute-heavy work. So it helps with your application, in terms of compute availability for processing those, queries and managing the cache and all that effort.
Yeah, think of it simplistically too. You open up Task Manager on your machine or Activity Monitor, and you have this huge list of processes they're running, and all of them are using resources. And what we're doing is we're making that list smaller. We don't have to worry about the durability. We don't have to worry about the backup. We don't have to worry about replication storage, right? So think of that as 3 things in Task Manager that aren't consuming resources, and you get that for your workload. That's big. So not only are you getting the right size instance to do what you need to do, you're utilizing more of that instance than you would do in a traditional architecture.
Yeah, you're utilizing the maximum of the instances available to you for what matters for your workload, rather than worrying about how much should I set aside for database and stuff like that.
They should name that like a managed service or something. That sounds like a good name. We should call it that.
Sure, we'll propose that to our service.
Yeah, we'll see what marketing says.
So that's the architecture within a region, right? Like a regional cluster, so to call, right? But now let's jump to the topic on global clusters, and then we'll talk about the automation just in a bit here. So if you look at this picture now, obviously it's probably very straightforward. I just copied that single region architecture across a few other regions here to show how global clusters work. So Amazon DocumentDB global clusters allows you to replicate data up to 5 secondary AWS regions, not 1, 2, but up to 5 secondary AWS regions. So you can have 1 primary region and 5 secondary. Obviously, I couldn't fit 5 regions in one slide, so I just chose to do 2 regions here, Tokyo and Oregon, right? So Again, just like what we discussed in the previous slide about the tasks being offloaded to storage volume, which replication was one of the tasks, even with global clusters, replication, I'm talking about cross-region replication, is offloaded to storage layer as well, right? So, and also even better, this is a physical replication from the storage layer of, in this case, Ohio or the primary region. So it's a physical replication from the storage layer in the primary to the storage layer of the secondary regions. And why is this important? Because being physical replication, the replica lag is very low. Typically, it's less than a second. In my own personal testing, I've seen it to be in the order of milliseconds, like 100 milliseconds is what I saw between US East and US West. So to replicate data across the country, it takes about 100 milliseconds. And the reason for that is, again, it's a physical replication on the AWS, leveraging the AWS infrastructure.
That's I think that's a key thing, right? Is it's all traveling over our backbone, right? You're not setting up, a transit gateway. You're not setting up a VPN peering or anything. No, it's just like you enable it, and it's utilizing that backbone, and it's not leaving us, right? And that's why you're getting such a fast response time.
Yep, absolutely. So you can, I'll talk about the use cases in a bit, but you can read the data written in Virginia. You can read the data in Oregon in about 100 milliseconds, which is pretty awesome. So that the replication factor is certainly an important thing to understand. Also, now we're talking about global clusters, and why, like you were alluding to earlier, Cody, why would you need multiple instances within a region and then multiple clusters within across the globe, is primarily for recovery from failure, right? The global clusters allows you to recover from regional outages should they happen. And let's say if an AWS region goes down, you can now promote a cluster in a secondary region to a standalone primary cluster. So in this case, you can pick, let's say, Oregon, and you say, hey, I want to promote this guy to a standalone primary. You can do that, and that process takes typically less than a minute. So it's very ideal for applications that have very tight RTO requirements. When I talk to customers, they say, hey, we have very strict RTO requirements. I've heard like as low as 15 minutes RTO if there is a disaster. And you need to have a capability like this where you don't have to worry about moving data when a disaster happens. All that you got to do is promote it and just start using the secondary cluster. And since the data is replicated in typically less than a second, your RPO, you can call it to be about a second, right? Because we know that the data replication is pretty fast. So the data loss is probably going to be for about a second or so, but you'll be able to recover and run with this newly promoted cluster in less than a minute.
And so, for those that aren't familiar with it, when we talk about RTO, that's your recovery time objective. I mean, that's what it's going to take to get you back up and running. Like something happens, your system goes down, it's going to take 1 second essentially for you to get back into a running state, which, I mean, I would argue, would you even notice? Like if it takes a second, would you even notice that, right? That's quick.
Yeah, absolutely. It is super quick. And that's our objective too, right? Like we want to keep it that way for our customers to, address those strict recovery time objective requirements.
So that's one use case. I have this region that's sitting over here in Oregon, or I have a region sitting over in Tokyo, and if something happens and I need to get away from Ohio over to Oregon, I can. But if I have resources out in Tokyo and I have resources in Oregon, like it'd be nice if I could use those so they're not just sitting there. Am I still able to read data from those?
Absolutely, you are. And I'll share that couple use cases slide in a bit. We call that as a data locality use case. Yes, you can certainly perform those local reads. Now, those instances do not have to sit idle waiting for a disaster to happen so that they can be utilized. You can still go ahead and use them and help your customers avoid those cross-region latencies. And I'll share that in a bit, just in a couple slides here.
Perfect.
So, just along this architecture and capabilities here for global clusters. So global clusters are available on DocumentDB 4.0, which is our engine version. So, we also have an older version of the engine, which is 3.6, which is compatible with MongoDB 3.6. And key thing to note is 3.6 is still not end of life. So DocumentDB fully supports 3.6. But if you have to use latest features like global clusters, you can go to 4.0 engine and start using it. And you can, like I said, you can deploy global cluster that spans across 6 regions, 5 secondary and 1 primary. And if you choose to do that, you can have up to 90 instances across the globe to scale globally, right? So that is pretty huge, right? Like allowing you to, scale the read request globally and supporting your users locally in those regions. So that at a very high level is how global clusters is architected. So if you take a closer look at just breaking those things into various pieces, let's say you have an application that writes data into your primary. In this case, let's just go with 2 regions for simplicity. We have a US East, Ohio, which is serving as a primary region, and you're writing data into that. And obviously now that data is going to be like sent to the storage volume and all that stuff. And then you have your US West region, which is Oregon in this case, right? Which is configured as a secondary cluster to the global cluster, right? So your primary is basically on the left-hand side sending the log records in parallel to both your storage nodes, the replica instances, and also the green box that you see over here, which is the replication server, right? So your primary instance is going to be sending data all over there. And then that replication server, we have, again, this is offloaded to the storage volume. So we have a replication fleet in the storage volume that is going to be replicating this, data, basically stream those records into the replication fleet on the secondary side, right? In this case, Oregon. So then, on that secondary side or the secondary cluster, the replication agent receives those log records, and then they update the log records to the instances. If the instance of the buffer cache of the instance has the data, it refreshes or updates the data, and then your application that can read it from the buffer cache, and it also parallelly updates the storage nodes as well, right? So that again at a very high level on what happens, right? At the storage volume, the replication fleet plays a critical role in replicating the data from primary to secondary, and also on the secondary side, updating the storage nodes as well as the buffer cache of those instances, so that when an application on the secondary side reads the data, it always reads that latest data.
So this is exactly what we saw earlier in the architecture, right? It's the 3 instances and 3 availability zones, the storage layer, the backups. What we're introducing here, this new concept, is that replication fleet that's taking care of that. And
Right.
That's all in that managed data layer, right? I mean, that's all, that's that piece I don't have to worry about, right?
Exactly. Yep. It's all handled. And again, like I said, it's more under the hood on how our replication fleet operates there. And it's a fully managed replication, if you will, right? So you don't have to worry about it. So now let's jump into a couple use cases here, right? So disaster recovery is a very common use case, right? So let's start with that. So the data is replicated near real time, like we saw in the previous slide, right? So global clusters allow you to be up and running in the secondary region in less than a minute's time, right? And when I say less than a minute, I want to be very clear that this is, the failover time or the recovery time at the data layer. Now, obviously, that would be like in layers above it, and they may take more time, which is practical. We have seen that, but our goal is to keep your database time minimal so that you can accomplish that strict RTO. So now if a regional outage occurs, your secondary cluster will be up and running in less than a minute. And how is this possible? Is because there is no data movement involved in this process, right? When you're performing a global failover. So the time to recover is just the time it takes to promote the secondary cluster, which is a part of a global cluster, to a standalone cluster. Right, so that process is what typically takes less than a minute. And also, if you want to migrate data across regions, you can use this feature to do so as well, right? So if you want to move data from, let's say, US East to US West, for whatever reason you decide to switch to the region, you can just migrate the data and promote that secondary in the West to primary or a standalone, and you'll be good to go. You don't have to perform any extra steps. So So it is super powerful when it comes to DR. Also important to note here is the cluster topology. I intentionally, I'm showing here two instances on the primary and one instance on the secondary. Now, even this one instance on the secondary, and this is again very unique to DocumentDB's architecture, right? You can have that one instance, or you can even run it headless, meaning you can run no instances on your DR. Let's say you don't want to use your DR cluster for performing reads, right? Your business requirement doesn't care for that. That's totally fine. Should and you have a little bit more flexibility in terms of your RTO, right? You don't have very strict RTO requirements. You're okay if the database takes about, let's say, 10 minutes to recover. You can run it headless, meaning you can run it without any instances, and hence you will not pay for any instance cost. And how is this possible? Is because the replication is offloaded to the storage layer, right? So the instance count or the presence of an instance on the DR side doesn't matter, right? So you can still fail over, and if you're running it headless, at that time you will have to basically spin up a cluster so that you can start querying. Without instance, you can't query the cluster, but you still have the data replicated in near real time to the storage volume. Again, that's how segregated or decoupled the compute and storage layers are, that you can run a cluster without instances.
So that RTO is increased on that computeless cluster just because it takes about 8 to 10 minutes to spin up a compute instance in front of it.
That's right. Yeah. So if you have a little bit of flexibility there, right? Like I said, the minimum I've heard is 15 minutes. So may not be a great fit there, but I've also heard like 4 hours is good enough for us. Okay, while other things are going on above the database stack, you can still work on, getting this instance spun up, and that takes about 8 to 10 minutes. So you can save a lot of cost, because often in on-prem, you will basically have like if not similar configuration, at least a lower configuration there, and you pay for that. Here, you don't have to worry about it. You can spin it up on demand.
It's funny. My tablet has a feature. I talked about this last time, where it shows you this date in history, or this date a year ago, or whatnot. These are the photos you had. And the photo that popped up this morning was the snowpocalypse, right? It's the big snowpocalypse that took down the entire state of Texas. And that's a big part, is there was a lot of data centers that were out of power for days. And focusing on what you just said is, our RTO for the database layer is 4 hours or something longer, right? Because when you lose, let's say if you lost a region, or if you lost your data center, right? It's not just the database layer that you're updating. You're updating your application, your front end, your middle layer, your web layer. Like, there's so many components to it. So it's easy for us to focus, and that's what we've done, is focus on making DocumentDB as fast as possible, getting you back up and running. Like you said, a minute for the data, or sub-second latency to replicate the data, because there's going to be a lot of other things going on, right? There's going to be so many other endpoints and application deployments that you're going to be working on. Your database layer, as quickly as possible, we're going to have that ready for you, so that when you're ready to connect, it's there.
Exactly. Yeah, it's plug and play, right? That's exactly how we want our customers' experience to be, and that's what we strive for. Yeah. So yeah, I mean, like that is one option, right? So you can save cost on a DR strategy by using that kind of architecture. And then the other use case, like Cody, you were asking about this on, can I read the data? Absolutely, right? So since the replication is offloaded to the storage layer, there is, little to no impact to your application performance, right? Because the application always interacts with the compute layer. So by offloading it, we take care of performance as well. And we offload to the storage layer, but still the replica lag is less than a second. And this enables you to use these secondary clusters to perform local reads. So think about use cases like content management, right? You can have your content author, let's say, sitting in US East, or maybe they'll sit somewhere else, but they'll still like write the data to US East. And your users, your customers, let's say in Asia, are going to be seeing this data in less than a second, right? Imagine the power of it, right? Now, if they have to go across like from APAC region into US East to just read the data, it is going to go through those regional latencies, right? Like there are going to be network latency and all that stuff. So you can now instead use the AWS backbone to replicate this data to your users, bring the data closer to users is a common mantra in all these modern application modernization initiatives. So this global clusters data locality or local reads use case is exactly for that, right? So your users don't have to now cross the regions and go through that latency. You can give them low latency access to data now.
Right. Instead of them hopping on their ISP to go to, Singapore to Australia and over, wherever it is, right? That long route. Now they just hit that AWS endpoint, and number one, the data is there. And again, we're utilizing our own backbone to get it there as fast as possible. I think there's a lot to be said about that customer experience that you give by that increase in speed from utilizing that.
Yeah, and it's like you do the change in one place and just goes across like 5 different clusters. And think about it. You can have up to 90 instances like that across the globe. So there should not be any scarcity for scaling your reads for these customers. So that's all great, right? So we have talked about how global clusters work, what are the common use cases. And like I said, when I talk to customers, they're like, hey, this is all great, but I tried to do this failover process and it takes a little bit manual effort. And how can you help us there? So this automation is a solution to that, right? It's one of the response to that, right? So here is a reference architecture, and I'll show a demo as well in after a couple slides here, right? So the prerequisite for this solution is to create a private hosted zone in Route 53. Now, why is this required? Best practice with global clusters, not just with DocumentDB, with any solution for that matter, is always to decouple your database endpoint from application, right? You don't want your database endpoint to be merged in your source code, so that if when you have to change it, you have to then deploy your application as well. We recommend that you keep it mutually exclusive, completely decoupled. So that's what Route 53 does here. So you would manage your database endpoints like DocumentDB offers cluster endpoints. So you'll add that as a record value to in a private hosted zone in Route 53, and the CNAME for that is what your application would be using. So anytime that endpoint changes, which it will, right? Like when you do a failover, your application doesn't even have to know, right? You'll just go there and change the endpoint, and your application starts talking to the new cluster. So so that's a best practice, and that's a prereq for this solution, right? So what the solution allows you to do is to seamlessly fail over to a healthy secondary cluster. Again, in the demo, you would see I have one cluster in East, one cluster maybe in East 2 or West, and if East is down and if other cluster is healthy, you would want to fail over to that cluster, right? So let's say this is the solution covers two scenarios: a disaster recovery, which is like an unplanned failover, right? And then a business continuity planning, which is more of a planned failover. So we're talking about disaster recovery, which is unplanned failover here. So what happens in this case is, when a region goes down, and you can define the DR event that you see as the first block in this architecture, you will define what this DR event is. Now, some customers may say, I want to just look at all my instances status. If it is not an available status, then I declare that as a DR. Some may say, I want to look at my public hosted zone in Route 53 and whatever the rules I have configured for failover detection, right? Like my EC2 instances are not healthy or whatever that is. So this event kind of varies from customers to customers. So you can define what that event is, but what the solution does is provides a Lambda function that you can trigger based on that event, right? So you can certainly say add a trigger, could define an event, add that as a trigger to your Lambda function. So when the first Lambda function, I call it failover to secondary. And as you can see from the naming convention, I'm a Java resource. I used to do a lot of Java development. So all those camel cases, and this solution is written in Python. So when you guys go through the code, if you see a lot of Java references,
so confused.
Yeah, so the failover to secondary Lambda function, basically what it does is it takes a couple parameters as input. It takes what the global cluster ID is. So every global cluster in DocumentDB will have a unique identifier. It takes that ID as input, and it also takes which secondary cluster do you want to promote, right? You may say, hey, my secondary cluster in Oregon is healthy. I want to promote to that. So you can give that secondary cluster's ARN, the unique resource identifier, and then it also takes this Route 53 level information, like, hey, what is that CNAME that your application is using, so that we can go and update the record value that corresponds to that CNAME, and also what that hosted zone ID is, so that the solution can identify that hosted zone and then go to that particular CNAME and update it, right? So it takes these four as input parameters, and as optional, you can also say if you want to delete the old global cluster, because once you promote or move to promote a secondary to a primary, the old global cluster is no longer needed. You can go ahead and delete it. The tool also, you can say if you're okay, you can give that as a Boolean true, and it'll just go ahead and delete it, or you can leave it there as is. So what it does, the moment you invoke this Lambda function, it removes that secondary cluster. In our case, let's say in Oregon, and then like it promotes it to a standalone primary. Then it also goes ahead and updates the Route 53 with a new primary cluster. In this case, again, Oregon was promoted, so Oregon's primary cluster endpoint is what it updates the Route 53 CNAME to. So your application, yes, it is going to see a brief interruption, and that's where we strongly recommend you use exception handling and retry mechanisms. But let's say in about a minute and maybe few more seconds from there for the Route 53 changes to propagate. Let's say even in 2 minutes, your application should be up and running, pointing to the new region now, the newly promoted cluster. And so this basically is going to get you back to business in, let's say, give or take 1 minute for database, 1 minute for Route 53. In about 2 minutes, you're going to be back in business, and then you can determine, hey, now I'm running just one cluster. What should I do? Should I build resiliency and add a secondary cluster and convert this into a global cluster? So to do that, you can again define whatever that event is. If you want, you can manually trigger the Lambda as well, right? And you can say, hey, call this convert regional cluster to global, which basically will create a global cluster and use this, whatever you just promoted, as the primary cluster in that global cluster. And then it also, the function takes an input array of secondary clusters, because you can have up to 5 secondary clusters. So you can provide the information on what that secondary cluster is, which VPC it should be, what security group, and all the details that you typically give when creating a cluster. You can provide that as an input to the Lambda function, and it just converts the promoted regional cluster to the standalone primary to a global cluster now, with that cluster being the primary and the new secondaries added to it. So that's what the second Lambda function does.
It's basically getting us back to that state that we were at.
Right. And the reason it is manual is, customers may choose, okay, US East 1 was down. I went into US West. Now I want US East 2 to be that secondary, right? Because so if the region is down, there's no point in saying add that cluster into my global cluster. So that's why we give that flexibility to customers to pick and choose which region and what cluster they want to add. And they can just trigger the Lambda to take care of converting to global and everything for them.
Yeah, there's certain decisions in a disaster recovery situation that you want input on, that you don't want a system to make all of those choices for you, because like you said, it's very important, what region I want to become my new secondary, especially if you did have a failure in one of them. So yeah, that makes sense. You do have to have those those gates, right? Those check-in points.
Right. Yeah. Especially in a DR situation. So when I presented this to a few customers, the question is hey, why can't you, take a note of what my original cluster status was and just automate that process? I'm like, great. Here is the answer to that, right? So this exactly does that. But to do this, it has to be a more of a planned failover scenario. DR is more for unplanned. But and some customers tell me, hey, we have this requirement for business continuity planning where we switch our regions every quarter for whatever.
Oh yeah, I hear that a lot.
Yeah, and the other classic use case for that I've heard is, hey, we have a lot of updates happening to the application, and we want to do this in a separate region first, and then come to this region, right? So great. Then you want to make the update, switch your users to point to that region, and then whenever you're ready, you come back to the old region. So that's business continuity planning, right? Be it for updates or be it just if you want to switch from one region to other. Now, in this scenario, there's no AWS regional outage or anything. It is just that you want to move to another region for your business, meeting your business needs. So what the solution does is, it leverages both the Lambda functions from the previous solution, the DR. But the only thing is, as one step before that, what it does is it takes a snapshot, basically, right? It does a describe cluster and takes the full snapshot of what this cluster topology looks like. Who's the primary? Who are all the secondaries? And then it says, okay, I have one primary, let's say I have two secondaries. And then one of the secondaries, what like you're going to say, right? Like in our example, again, East 1, East 2, and West. So let's say these are the regions we're dealing with. East 1 is primary, West 2 and East 2 are secondaries, and you want to go to West 2 as your new primary. So what this failover and convert to global Lambda function does is it first takes a snapshot. It understands what that cluster looks like, which VPC it was deployed to, what security group and everything. It takes all that information, and then it does a transpose, right? Meaning it takes the secondary cluster, West 2 in this case, and makes it to primary. So the East 1 and East 2 are going to be secondaries in this. So as an end user, all that you give as input to this particular function are just 4 parameters again: the global cluster ID, the secondary cluster you want to promote, and the hosted zone ID and the primary cluster, the primary, the CNAME that your application uses. So you just give those 4, but the net result of it is going to be, it's going to be switching over to other region with the primary of your choice now, and all the other, including the old primary, as secondaries to the new global cluster. So, so this is more for business continuity planning, where you can just convert move to one region, from one region to another region. So it automatically deletes the old global cluster, creates a new global cluster, adds all those regions. Everything is handled by the solution on your behalf.
Yeah, I'm hearing more and more customers that need that. Not just from DocumentDB, but from their entire workload. They want to. What is the Netflix tool? The Chaos Monkey, Chaos Ape.
Yeah.
They essentially are doing their own version of that, right? They want to make sure that if something happens, they're good. Like, they know what to expect. And I fully support that. My big thing is be proactive everywhere you can instead of reactive, and destroying your footprint in one region just to see what it does on your time is about as proactive as you can get. So I love this solution. This is cool, so that they can do that continuity testing.
Absolutely. Yeah, it lets them, go where they want to, right? Like in terms of regional switching and all. So let's take a look at a demo on how this all works, right? So I have a couple of DocumentDB global clusters here. I have a global demo new, and by the way, this is how a global cluster would look like. You can simply convert a regional cluster. So this is a regional cluster called Getting Started. If I want to convert it into global, I just go over here, say add region, and I just give whatever information, which region I want my secondary to be in, what is the global cluster identifier, and so on. But we already have created a global cluster. So I have 2 global clusters here. I have one called global demo new. It has primary in US East 2 and a secondary in US East 1. My primary is called cluster 22, and cluster 3 with some random numbers here, which basically is a result of a testing I did with the tool earlier, is our secondary cluster in US East 1. Now let's say, and also before I get into the demo, right, I also have this Route 53 hosted zone here, right? So again, this is a private host zone. I have a hosted zone ID, and you can see that the type is private hosted zone, and I have a record name called primary.sample.com. Now this is the CNAME that my applications will use. And when they use the CNAME, it will be resolved into a record value of whatever is a cluster endpoint, right? So that's my prereq. So I have that set up, and then I have this Lambda function over here, right? So if you look at this, I have actually 3 Lambda functions, right? I talked about all these 3 in the slides: failover to secondary, and convert regional cluster to global cluster, and failover to global, right? So failover to secondary and convert regional to global are the ones that you would be using in the DR scenario. Failover and convert to global basically calls these 2 in tandem, right, in sequence. So let's start with our first, right, a scenario here, DR scenario. Let's say we want to take this global demo new, which is over here, right? Global demo new. And I want to take this cluster 3, which is secondary, and promote it to primary. So I'm going to do a live demo. We'll see what happens. So, what's happening behind the scenes is it is going to, after all the validation and stuff, it is going to start, promoting our secondary cluster. It's going to be removing our secondary cluster, which is cluster 3 here. It'll remove this from global demo new and convert it into a standalone primary cluster, which again, as a process, it takes about a minute or so. So you can see that I have like all this, what do you call this? This CloudWatch logs here, right? And you can see it already started. So it'll tell you what steps it is on. It has started to promote the failover, and it is waiting for that failover process to complete over here. So it does, like I said, it takes about a minute. So it's going to keep polling for that to see if that failover process is complete. And you can see that here as well. If I refresh the screen, you can see that the process kicked off, and it is promoting the secondary cluster. And it's the primary cluster inside the global cluster is in modifying stat, knowing that, okay, I'm going to let go of the secondary cluster, because the moment the secondary is promoted to a global, it is not going to be part of that global cluster. So that's the global cluster also has to adjust itself to know that, so that it no longer will replicate data to that. Right. So this process will take about a minute's time. And then after that, it'll also, if you pay attention here on the cloud Route 53, it points to some other cluster right now. But when we are done here, it should point to this cluster 3, which is now going to be so right now it points to cluster 22, which is the primary. But since there is a disaster, at least that's what we're trying to simulate, once cluster 3 is promoted, it should point to the endpoint pertaining to cluster 3.
I think it's important to point out what Route 53 is really doing here. I mean, you touched on it, where the old way to do things was to hard code or have an environmental variable or have a configuration file. And let's say that you had a configuration file for your application, and it had the address of your main cluster, your primary cluster, right? Well, when we do this failover, you can't use that address anymore. You're going to use that secondary one, right? Which in the old sense, that means that you would have to go update your config file. In some cases, that means that you would have to restart that service for it to recognize it. It's huge what Route 53 is doing here, because you're saying always use this name in my application no matter what. Behind the scenes, the world could be churning. A region could go down. We could be promoting another one, but your application is just saying, no, I'm going to this namespace. To your point, handle, the temporary outage, the minute or two that we're waiting. And then when it comes back up, your application is running like it was before. Like behind the scenes, things changed, but you never once had to touch your application. You never once had to go modify config files or environmental variables. No, you've set that parameter, it's using the correct name, and it's going to continue using that same name. And that small piece right there is massive. I think that's so huge in the solution.
Right. And think about this, Cody, right? If you it's certainly the application is completely unaware of all this happening behind the scenes. And when the application also implements the best practices of exception handling, right? Your application is going to say, okay, I'm not able to get a response from the server because it is down and this failover is happening in this 1 minute or whatnot. Retry, right? Just keep retrying there's a blog out there on exception handling retry that I have put there, which talks about exception handling with jitter, or exponential backoff. So you retry, increase the time, retry, and over a period of time, when this process completes, your application will automatically start writing to the new cluster, right? So if you have that exception handling and combined with this Route 53 configuration here, yes, your application is like totally hands off. And in reInvent, I did this demo, and I was like talking, and like on a big screen, I showed all these errors, like exceptions, and all of a sudden those all went away, and the application started writing again, right? Because I had those best practices implemented. So it goes a long way in terms of how resilient your applications can become.
Yeah, your region just went down, but don't worry, your database is okay. What is Gone in 60 Seconds? I'm going to take this back to a movie. There's a movie Gone in 60 Seconds with Nicolas Cage,
Yeah.
and they're doing like the big
Yeah.
scene, and a wrecking ball, like a cop car, is chasing the Nicolas Cage, and the wrecking ball hits the wall, hits the car. The car goes through a wall, and one of the other cops comes up to him and says, "Are you okay? Because you just went through a wall." Like, that's pretty big. I just relate that quote to this. It's like, is your application okay? Because you just lost a region. No, we didn't even notice. We're good.
Yeah, exactly. That's how it is. So if you see this now from cluster 22, it's already changed to cluster 3 because the failover process completed. So if and now your application, it's not even going to notice. It's just going to say, okay, I did my retry, and now I'm going to go and hit this cluster 3 endpoint. So if we go back to our DocumentDB cluster over here, you can see that you have only cluster 3 over here, right? So your cluster 3 has now become a regional cluster. This is what, if you remember, so this Lambda completed, and we chose this cluster 3 to be promoted as a regional cluster. There's no longer a global demo new because I went ahead and deleted it, right? So now I have a regional cluster and no global cluster, but guess what? I'm up and running. My business is all like, good. I'm able to talk to this cluster and life is good. But I do not have resiliency built in. So to help with that is what the second Lambda function comes in. So I know that this cluster 3 is now available as a regional cluster. So then I go over here, I trigger my second Lambda function. And if you look at the second Lambda function, what I'm doing now is, earlier I was in East 2, but now I know East 2 is down, right? Again, at least I'm simulating East to be down. So I'm saying, hey, take this primary cluster and create a global cluster called global demo TS. And if you're wondering what TS means, it's Twitch show. So then I'm giving an array. In this array, I'm just like being frugal, giving only one secondary cluster, which is US West 2. And I'm calling that cluster whatever I want, right? Like 21. And I'm giving all this information about, that you typically use to create a cluster, KMS key and all that stuff, subnet groups, a security group, basically the network configuration and everything. So now with this, if I trigger this, it should basically, if you what this does is, if you go over here and look at one more level up and look at this, it basically is gonna say, hey, I want to convert this guy into a regional cluster, right? So, well, it already completed. So what it did is it converted our primary cluster into a global cluster called global demo TS, and it finally added the secondary cluster we provided. So it took about 15 seconds, but it completed, meaning the function completed. But if you go to DocumentDB now, if I refresh the screen, you would see global demo TS, right? And you can see cluster 21 is in creating status. Now, obviously, it's going to take about 8 to 10 minutes for this cluster to create. But once it is done, you can start using that. Or if you want to, fail over to that, you can do that as well, right? So that's our first use case, disaster recovery, right? Now, the second use case, which is business continuity planning, I'm just going to trigger this and go to the presentation, but I'll just like quickly walk through this, right? And very simple in terms of inputs. Here, we now work with a second cluster, which is global demo 1. And what I'm saying is same set of inputs, right? Like similar inputs. I'm saying in this global demo 1, I have, again, 2 clusters. Cluster 22 is my primary, and cluster 1, with some numbers here, is my secondary. So I'm saying take this secondary cluster and promote it. Now, also the same thing with this did not change from previous time in terms of Route 53 update. Now, what this does, like I said, is the net outcome of this when this function completes. I'm just going to go ahead and trigger this, right? And when this function completes, the net outcome would be you'll still have a global demo 1, but this would be transposed, right? This will become cluster 22 will become secondary, and cluster 1 will become primary. That's the net. That's going to be the net outcome. And again, this is going to take a few minutes to run. But when it is done, that's what you would see. So it does all the heavy lifting of promoting, deleting, updating promoting the secondary cluster to primary, deleting the old primary, updating the Route 53 endpoint, and then converting the newly promoted cluster into secondary, into a global cluster with cluster 22 as its secondary. So those are the series of steps it does. But as an end user, you just had to click on that one button. And again, I clicked on this button to do this, but you can also configure the DR event, like I said before, and automate that as well. Bottom line is, to you is available a Lambda function, and you can pick and choose on how you want to use it.
Well, I think the other benefit here too is for those organizations that are in this multi-region architecture, right?
Mm-hmm.
Having test plans is key, right? Because you don't want to be woken up in the middle of the night and not have any idea whatsoever what to do or what to expect. And if you're struggling with creating a test plan, like how do I test a region being out, or how do I test something like this? You click a button. I mean, you clone the repo and you click a button and you've just tested it. Like that the value from that can't be understated. That's big.
Yeah. And talking about that, here is the repo at Cody. Thanks for sharing that with the group here. So again, all the architecture that I just explained is all here, and some sample inputs for you guys to copy. And to get started, all that you got to do is clone the tool and deploy the Lambda functions, run the script, create a S3 bucket. All that this does is it automatically takes the code that you cloned, uploads it to S3. And then I also have a CloudFormation template for what is that, quick start or one-click deploy. So you just deploy this CloudFormation template, provide the same bucket name as a parameter, and you'll have all that you saw on my screen, including the IAM roles and everything, right? All those things would be deployed for you, and you should be able to start doing what I just showed you right now.
And just like you've kind of walked through the Lambda console here, after they clone this and deploy this, they'll be able to go in and, if they want to tweak anything in their Lambda function, they'll be able to do that.
Oh, absolutely. So the source code is open source as Apache 2.0 license. So feel free to make any changes and use it in your environment. If you think it's a good contribution back to the community, submit a PR. I'll be happy to review and merge and have a conversation with you if needed. So this is also completed now, but I know that this is already creating those new clusters, and right now, I zoomed too much.
we really saw that it was creating. I love it.
Yeah, so it did that. So again, it's gonna take so if you can see here, like I said, cluster 22 now became secondary and cluster 1 became the primary, right? And it's still working on completing the process, but you can see the Lambda function is done, and it just took a couple minutes to finish that. So that's the solution. I know we have a couple minutes, so I'll go back to the slide to finish off with what's new. And we will be doing a more thorough show on the new releases probably next month with our product manager.
Teaser.
Yeah, teaser. But yeah, we recently launched free trial. So if you like what you see, you can go ahead and use DocumentDB for free for about a month and try all those new capabilities and see if your business functionality can be solved by DocumentDB. We also have Graviton instances to help you save costs. We've seen up to 5% or 5% price improvement or reduction in cost, and up to 30% performance improvement. We launched role-based access control user-defined roles to help customers define those fine-grained roles and use combination of built-in roles and those user-defined roles. Global clusters you already saw. We also, being a native AWS integration and AWS service, we integrated so many other AWS services. AWS backup integration is something we launched last November. So you can, if you're managing backups from various resources for multiple databases all in one place, you can now add DocumentDB to that list and centrally manage DocumentDB backups as well. So again, we'll go over all this in subsequent shows. So I just want to give you a teaser, like Cody said. And if you want to learn more about DocumentDB, here is our link to resources where you can stay up to date with what's going on. And also we have hands-on workshop that folks can feel free to use. It's public facing and it's free, so use it. Go through the hands-on labs to get more familiar with DocumentDB. So that brings us to the end of this topic. are
Well,
there.
thank you, Karthik. That was awesome. I felt like, again, can't understate how powerful these tools and these scripts are. So recommend everybody go check that out. The links are here. And thanks for joining us today. Appreciate it.
Cool. Thank you, Cody, and thank you, folks.
We got to play with my paperweight. See you, Karthik.
All right, man. Take care. Bye-bye.